Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to discuss what is termed as hypergeometric distribution. A hypergeometric random variable is often found in many fields with what uses in acceptance sampling, electronic testing, and quality assurance, where testing is done at the expenses of the item being what tested. For example, maybe we have food and drug authorities in a particular country. And then what they do is that they test the quality of what goods and medicines that are sent to the general public to use. Okay, so for them to test these particular goods, a bigger population of what these goods will be sent, and then these authorities will just select a sample out of what the bigger goods that is being sent, and then they are going to base their decision on the sample that is being selected to be tested. Okay, on that. So this example is termed as what a hypergeometric random variable. Okay, so when these random variables are being selected out of what the population, it is what without what replacement. Okay, so with this without replacement idea, that gives us a clear distinction between what the hypergeometric distribution and what a binomial distribution. Note, the binomial distribution can be used to approximate what the hypergeometric distribution. But what makes the binomial distribution different from what the hypergeometric distribution is that for hypergeometric distribution, the trial of the hypergeometric distribution are not what independent, okay, and then its sample are without what replacement. Whilst for the binomial distribution, the trials are what independent and the sample are with what replacement. Okay, so we been understanding the introduction of what the hypergeometric distribution. Let's dive into how we will understand the PMF for the hypergeometric distribution. So here we are saying that the probability distribution of the hypergeometric random variable x, the number of success in a random sample of size n selected from n items of which k success, right, of which k success and n minus k failures, cause the hypergeometric distribution s. Okay, so we are saying that probability of x will be equal to k combination x times n minus k combination n minus x divided by n combination n. Okay, so here the k here will be what the success. Okay, the k here will be what the success, and then x here will be what the random variable. Our n will be what the n item, right? I mean the bigger population. And then our n will be the sample that is being selected from the n item, and then already we know our x to be our random variable. Okay, so this is the PMF for the hypergeometric distribution. Sometimes, as usual, they can also ask us to calculate for the mean variance of the hypergeometric distribution. Okay, we are saying that if x has the hypergeometric distribution with a parameter n, k, and then this our bigger n, then our expectation of x is equal to n times p. Okay, and then our variance is equal to n times p times 1 minus p times n minus n, all divided by n minus 1. Okay, where our p is equal to k divided by n. Okay, so that is what we have here. Okay, yes, so there are some ideas that we have to also get here. We can use the binomial distribution to approximate the hypergeometric distribution only on one condition. If our n is very small and our n is large, then we can use the binomial distribution to approximate the hypergeometric distribution. Okay, and then for once we see that our n is very small and our n is large, it has to fulfill this criteria, right? When our n is less than or equal to 0.05 times our bigger n. Okay, so this is the mathematics behind the hypergeometric distribution. Okay, so in our next video we are going to solve work examples on the hypergeometric distribution. So please don't forget to watch that video, because once you have known the mathematics behind, we have to solve more examples to get clear understanding of the distribution. Okay, if you haven't subscribed to Statistics and Mathematics YouTube channel, please kindly subscribe, like and share so that this video will get to your friends for them to also be blessed. So bye, have a lovely day.